Welcome to ReneEnergy.com on YouTube, the hub for all things renewable energy and sustainability. Our channel is dedicated to bringing you the latest innovations and insights in green energy, including cutting-edge developments like green hydrogen. Whether you're a sustainability veteran or just beginning your journey, we have something for everyone. Join us on this channel to explore inspiring projects for a sustainable tomorrow. We bring you the latest in renewable energy, sustainability, and cutting-edge technologies. And don't forget, for more in-depth information and resources, visit our website and subscribe to our newsletter for the latest updates and exclusive content.
If ChatGPT were a country, it would consume more electricity than Ireland. That's not clickbait, it's a reality backed by emerging data. In this video, we're going to unpack the shocking truth about the hidden energy cost of artificial intelligence, and why one of the most powerful tools on the internet could be accelerating us toward an energy crisis. By the end of this video, you'll see how something as simple as typing a question into a chatbot connects to massive data centers, billions of parameters, and the same amount of energy it takes to power entire cities. But more importantly, you'll learn about a clean energy solution that could power this AI-driven future without burning out our planet. Let's begin with a number that will stop you in your tracks. ChatGPT is estimated to consume about 564 megawatt-hours of electricity per day. To understand that scale, consider this. It's enough energy to power roughly 50,000 US households every single day. Just think about what that means. The same energy used to keep the lights on, refrigerators running, and heating systems active in 50,000 homes is being used daily by a single AI service to answer questions, draft emails, write code, and generate poems. That's the unseen cost of every ChatGPT session. But the comparison gets even more dramatic when you stack it against a real country. Ireland, a developed European country with a population of around 5 million people, uses approximately 28,000 gigawatt-hours of electricity per year. When you convert ChatGPT's estimated 564 megawatt-hours per day into an annual figure, you get about 206 gigawatt-hours per year. That's nearly 1% of Ireland's total electricity consumption, and we're talking about just one AI platform. We haven't even considered Claude, Gemini, Midjourney, or any of the thousands of new generative AI services entering the market. So where is all this energy actually going? The answer isn't just one place. It's spread across three main components: training, inference, and infrastructure. First is training. Before ChatGPT can answer your question, it had to be trained on massive amounts of data using enormous computational resources. Training GPT-4 alone required an estimated 50 gigawatt-hours of electricity. That's the equivalent of powering 50,000 homes for 10 hours straight, just to teach the AI how to understand and generate human-like responses. Once the model is trained, the energy cost shifts to inference, which is the process of responding to queries in real time. Every time you ask ChatGPT a question, the system pulls in power to retrieve information, run calculations, and generate a relevant answer. Each individual query consumes about 10 times more energy than a standard Google search. If you're imagining servers working overtime, you're right. The data centers powering ChatGPT are vast, power-hungry complexes that not only require energy to compute, but also to cool. That's the part most people miss. These buildings generate so much heat that they require industrial-scale cooling systems that run constantly. In some cases, these cooling systems consume nearly as much power as the computing itself. Add in the water usage, millions of gallons per day at some facilities, and the carbon footprint of a single AI platform quickly grows from invisible to undeniable. And this isn't just a current problem, it's an exponentially growing one. Since 2017, energy consumption by data centers has doubled, largely driven by AI. If trends continue, projections show that by 2028, AI alone could be responsible for half of all data center energy usage globally. To put that in numbers, the US Department of Energy predicts that data centers could consume 580 terawatt-hours per year by the end of this decade, more than the entire state of California consumes annually. In Northern Virginia, one of the largest data center hubs in the world, utilities are already running out of capacity. New projects are being paused or rejected because the local grid can't supply enough power. The situation is serious and it's spreading. And if we zoom out to look at the environmental impact, the future becomes even more concerning. The tech sector has traditionally been seen as clean, but AI could change that rapidly. Without intervention, AI-driven data centers could become one of the largest carbon emitters on Earth, rivaling aviation and shipping. The narrative that tech is green because it's digital simply doesn't hold up under the weight of electricity and emissions data. But the big question is, why is this happening now? Why has AI's energy use exploded in such a short amount of time? The answer is scale and stagnation. AI capabilities have grown exponentially, while energy efficiency has largely stagnated. For decades, Moore's law ensured that chips got faster and more efficient, doubling performance every 2 years. But those gains have slowed dramatically. Meanwhile, AI models like GPT have grown by hundreds of thousands of times in size since 2012. GPT-3 had 85 billion parameters. GPT-4 reportedly exceeds 1 trillion. Each parameter takes energy to train, store, and use. Multiply that across billions of queries and the math becomes clear. AI is a major energy consumer. To make matters worse, the AI arms race between companies like Google, Microsoft, Amazon, and Meta has intensified the energy drain. Everyone wants the biggest, fastest, smartest model, and that means pumping more and more electricity into every new release. On top of that, user demand is skyrocketing. The average user might make 20 to 30 queries per day. Multiply that across hundreds of millions of users, and the energy consumption scales into the stratosphere. The good news? There's a solution, and it doesn't require us to stop using AI. In fact, it allows us to continue growing AI responsibly, while avoiding a climate disaster. That solution is green hydrogen. Unlike fossil fuels, green hydrogen is produced by splitting water using renewable energy, solar, wind, or hydro. The result is pure hydrogen gas, which can be used in fuel cells to produce electricity, with water vapor as the only byproduct. No carbon emissions, no air pollution, just clean, scalable power. Tech giants are already exploring this solution. Microsoft has tested hydrogen fuel cells for data center backup power. Google and Amazon are running pilot programs. And if predictions hold true, hydrogen could become cheaper than natural gas by 2030. Countries around the world are investing in hydrogen infrastructure. Japan, Germany, Australia, they're all racing to become leaders in the hydrogen economy. Ireland, in fact, could play a key role here, given its strong renewable energy resources and proximity to Europe's hydrogen ambitions. Imagine powering AI with fuel that's not only clean but abundant and cost-effective. Instead of data centers choking power grids and contributing to climate change, they could become models of energy innovation. This isn't theoretical. It's happening right now. But to make it mainstream, we need awareness, investment, and policy support. So what can you do? Start by understanding the trade-offs. Every AI query has a hidden energy cost. That doesn't mean you should stop using AI, but it does mean we all need to start asking better questions. Not just to ChatGPT, but to ourselves and our leaders. Where is this energy coming from? Who controls it? And what will it cost us if we don't change course? If this video opened your eyes to the energy demands of AI, make sure you subscribe and join the conversation. We're building a series on the energy impact of digital technologies and the clean energy solutions that can power them. Next up, we're diving into how social media platforms like TikTok and Instagram are consuming more energy than you think, and how they compare to your favorite streaming services. We'll also take you inside a real hydrogen-powered data center to see the future in action. In the comments, let us know. Were you surprised by how much energy ChatGPT uses? Do you think AI should be more energy efficient? Or should we focus on powering it with clean energy? What questions do you have about hydrogen and AI sustainability? We're reading everything and shaping our next videos based on what you want to know. If you're ready to learn more, check out our video where we calculate the real carbon footprint of your everyday tech habits. Spoiler, it's worse than you think. Hit that subscribe button and notification bell so you don't miss what's coming next. Because the future of energy isn't just about how we live, it's about how we think, build, and innovate. And with hydrogen, that future could be a lot cleaner than you ever imagined.
Thanks for tuning into the ReneEnergy.com YouTube channel. We trust you found this episode enlightening and motivating. There's a world of innovation and opportunity in sustainable energy, and we're delighted to share this journey with you. Stay in the loop with the latest on renewable energy and sustainability by visiting our website and subscribing to our newsletter. Your support is immensely appreciated, it's truly invaluable to us. Don't miss our next video on new trends in renewable energy. Follow us on social media for the latest updates. Enjoyed the video? Like, subscribe, and share for more green insights. Thanks for watching.